got delegates from medical students right up to senior professors. It's what Gasoc's all about. We're a trainee-led organisation, but our events appeal to everyone, and we support and encourage the mixing of skill disciplines and the mixing of levels of training so that you can really engage with each other and really develop your interest in global surgery. And on that point, I'd like to ask you to consider your fellow delegates as a resource for the day. Make sure you talk to each other, make sure you discuss your interests. We've had so many collaborations and projects coming out of our events, and I'd really encourage you to talk to each other, link on the app, network. It's a great opportunity for you all. Our day is focusing on technology.
impact. Now, WHO has mission statements. It has a loose framework around what they consider healthcare technology assessment to be. But it is broad brushstroke. So it's about not the single intervention, it's about the whole wider impact. So what might be the effect on the whole technology spectrum? So the social aspects, the economic aspects, the organizational, the ethical issues, these all have to be taken into consideration. And the importance of that is ultimately whatever we do, if it's going to be impactful, it's got to change or inform policy-making decision. So if we work in isolation and ignore the wider aspects, it's very unlikely that we're going to actually make a change in policy. Now, this is where the difficulty comes in, because in high-income countries, we have fairly well-established frameworks as to how we can go about healthcare technology assessment. One of the most widely used is the ideal collaboration. So this is the rough framework outlined here. So ideal stands for innovation, development, exploration, assessment, and then there's this phase 4, the longer term evaluation. So when you have your new idea, your very early technology, you're working at the stages 0 to 1. So it's very small scale. You're just testing out the innovation. Small numbers of patients, very tight cohort, very highly controlled. As you begin to gain confidence in your technology, you get a bit bolder and you start trying it in other areas. You may have other collaborators beginning to come on, and this is the development stage as you are evolving iteration by iteration your technology. So you're at the 2A stage. You then begin to grow it bigger, your networks expand, your product becomes more defined, and you're in the 2B stage before going on to the bigger assessments where you're really spreading out into big multi-center studies, probably randomized controlled trials, and you're on stage 3. And by stage 4, you're actually doing that very detailed cost evaluations, health economics, which are going to inform policy. Now, this is all well and good in a high-income setting where we have the resources to do that. This is clearly going to fall short where the resources are sparse. So what you will find in low-income settings, you can probably do the early phases, the early evaluations, but there is no way it's going to be very difficult to do these bigger pieces of work that ultimately are so important if we're going to change policy. There is a very useful framework put forward by WHO, and this is called their Technology Reflection Guide. And it works on 3 levels: effectiveness, appropriateness, and implementation. So what I would suggest to you, if you're thinking about doing some sort of research, developing some sort of technology, it's good to use this framework to reflect on this at the very start. So in terms of effectiveness, is your intervention right for the actual country, for the context that you want to test it in? Are there other technologies that actually might be better? What are the potential competitors? And importantly, what are the potential costs within that particular environment? So the appropriateness of it, how does it fit in with the policy of that country? Most countries have ministries of health with their own policies. What you want to be doing is to be working with them and developing interventions that align with their policy and that aren't tangentially opposed to it. And that way, you're going to get buy-in and support. Often interventions have other things that they require, other ancillary support. Is that available? Will the local clinicians buy into it? If you show it's a benefit, is it likely to be taken up? And implementation, these are the practical things about actually getting your technology into practice. So it's about the supply chains. It's all very good doing an intervention, but if you haven't got the supply chains for the sustainability, it's going to collapse. You may develop a diagnostic test. That's brilliant. A cheap, reliable diagnostic test you can use out in the field. But it's no good if you don't have the treatments to treat the condition once you've made the diagnosis. So we have to be very careful about working in isolation. I just want to introduce two concepts which you'll hear a little bit more, I'm sure, from Jenny and Raj Ganaran later on today. And this is something we've been thinking a lot about when we're trying to design our innovations and working with our engineers. So the concept of Jugaad or frugal innovation. So this is finding yourself in a low resource setting and doing more with less. It's not about Ryanair. This is not about cheap bucket flights, no frills. This is about high quality, but done at less cost. So in effect, you're adding value. And it's also about being context specific. So whatever you do has to fit the local context. And probably more than that, if it's going to have true impact, it's got to be scalable. So is it fit for other low resource environments? And these are the 6 underlying principles of frugal innovation. Seeking opportunity in adversity, doing more with less, thinking and acting flexibly, including the margin, and sometimes just plainly following your heart. So an example that everyone will be very familiar with, it's very well publicized, the mosquito net. So in the UK, we spend an awful lot of money on prosthetic meshes to mend hernias. Hernias throughout the world are a healthcare burden, and it consumes a huge amount of resource in the NHS. But you can do the same operation just as well with just as good outcomes if you use a cheap piece of mosquito net. The other concept is this of reverse innovation. So traditionally, technologies have been developed in high-income countries, and they have slowly made their way into low-resource settings as and when they become applicable and affordable. But reverse innovation flips this around. So a necessity is very much the mother of invention. And there is huge innovation in low and resource countries. There has to be. It is the way to adapt and cope. And it is about working with that innovation, developing it, and then there is a reverse flow back into high income countries. And in this way, the high and low income countries can be partnering together to pull up the standard, the technology across the globe. And an example of that is the GE ECG machine. So this was a concept that ECGs are a vital bit of surgical equipment. And it was about working with local engineers, Indian engineers, who really knew the context, stripping it down, making it rugged, transportable, and importantly, cheap. And in that way, they developed an ECG machine that was not just good for use in rural India, it actually became a bestseller in health-conscious, high-income countries as well. So what do we do in the Global Health research team here in Leeds? We're a little bit different because most international health organizations have their global health expertise. They may have a bit of health economics as well, and there's usually some sort of clinical guidance. And I think what the NIHR bit allowed us to do, really, was to bring in two very different elements, which does lend us a degree of uniqueness. And those elements are the research elements, the clinical trials, the evaluation, and also the engineering. And it's formed on a track record going back 10, 15 years. So we've always worked in clinical trials. We have a Royal College of Surgeons surgical trials unit that works within the NHS. We have a surgical medtech cooperative that works, again, innovating within the NHS. And it was about drawing on these strengths and trying to apply them to low-income settings. So we were starting off reasonably from scratch. We had to build our networks, and that's how we came to be in Sierra Leone and Northeast India. We then had to do the research priority setting. We had to define the needs, not just the surgical needs, but also what could be delivered and developed within that whole healthcare system. Once we knew what we had to do, then we gave that to our engineers and said, come up with the solutions. They came up with the solutions, and we brought in the clinical trials expertise, the evaluation expertise, the health economics, that hopefully will generate the data we need to actually then persuade policymakers that what we're doing is a good idea. As you can imagine, you come up against huge obstacles along the way, and some of them that we came up against are listed here. If you're going into low resource settings, the obvious things sometimes you forget. You forget that there may not be a consistent power supply, and this may have a huge impact on what you want to do. You've got to think about any surgical intervention, you need sterility. If you haven't got power and sterility, you're really quite stuck. And I've talked before about the supply chains. Networks and partnerships are hugely important, and they will determine actually what is feasible. You have to have people who can do the research with you. And you may have to go in, you may have to train them, you may have to put the methodology in there. You have to think about ethics and regulations. And importantly, whatever you do, the studies you do need to be insured. So you have to do your research in low-income countries as you would in the UK. Sustainability is all important. How do you disseminate the results, and also the unintended consequences? And this is the difficult bit, because it's all very well and good doing a nice piece of research, innovating in one space. If all you're doing is drawing resources from another, it's essentially a nil balance. So in Sierra Leone, we work in Connaught Hospital in Freetown and Masanga, which is in the jungle. And when we went out there, it's very, very different. If you walk around a hospital ward in the UK, you will see old people with multi-morbidity. That is the healthcare burden. In Sierra Leone, you will see young men with broken limbs, and it is obvious where the need is. In Northeast India, the main problem in working out in the rural communities, if you are unwell, there are just not the diagnostics. These hospitals don't have CT scans. They might have an X-ray. They might have an ultrasound machine. And so it became obvious to us that if we could do a diagnostic laparoscopy on someone who is acutely unwell, that would be a really beneficial thing to do. So in Sierra Leone, we've implemented our research innovation is about taking high-tech innovation, this Alizarov frames to stabilize lower limb fractures, and hopefully we will be able to go from the current standard of care, which is 6 to 8 weeks of bed rest with skin traction, to the situation where we can put Alizarov frames on, we can get people up and about within days of their injury and back home. Yeah. In Northeast India, our aim is to implement laparoscopic surgery. And to do that, we've set up a target study. This is a training study. We are training the rural surgeons, and we're putting in place the facility to actually support them. So we put in the training, we put in the proctorship, so we have a team of proctors who go out to the individual hospitals and support the activity, and we are populating a registry. And our engineers are helping us. They are redesigning the devices we need for laparoscopic surgery so they are suitable for the low resource setting. And they have also designed low-cost simulators for skills training. So what have we got to do now going forwards? We know what we're doing. We've put in place our research interventions. We've got to deliver them. Once we've delivered them, we need to disseminate them. We need to demonstrate their clinical and cost effectiveness. And the final bit of work is then scaling it up and ensuring sustainability. Thank you very much for listening.
Thank you so much, Professor Jane. That was fantastic. I'd like to take this opportunity to introduce a panel who will be chairing the rest of the morning sessions. So if you'd like to come on, we have Mr. Stuart Ferguson, who's an ST8 in general surgery at the Royal Alexandra Hospital in Paisley, Ms. Ori Bajomo and Ms. Denise Osei Kufor, who are CTs in plastics and ST3 Reg from Thames. So thank you very much. These guys are valued members of our committee. They're going to be chairing the rest of the sessions.
We are just going to take questions at the end of all the talks at the moment. Okay, so we've
Okay, so I'd like to introduce our next fantastic speaker, who is Professor Jenny Dankelman. She's a professor in minimally invasive surgery and interventional techniques at Delft University of Technology. Her interests are mainly in research projects looking at designing novel medical instruments and simulation systems, and also focuses on patient safety. She started a number of projects to develop affordable multifunctional surgical instruments, particularly in use in low-resource settings. So she'll be speaking today on improving global access to surgery through the development of safe and affordable surgical devices.
Thank you very much for the introduction, and also thank you very much for inviting me here on this excellent conference. I'm really honored to be able to speak on the first conference like this. My name is Jenny Dankelman from the Delft University of Technology. What we do is at a group from the minimally invasive surgery intervention group that I'm leading, we're developing new instrumentation, advanced technology for all kinds of minimally invasive interventions. What we work on is on these kind of devices, making tiny devices, steerable devices. We were able to develop the most tiny devices that exist in the world, that are all direction steerable, steerable needles, steerable catheters, really advanced technology. We also develop training systems for laparoscopic procedures, for epidural needle insertions, for meniscus procedures, and we're trying to improve the processes at the operating theater. And well, we have nice solutions, and especially we got that with nice collaboration with a lot of hospitals in the Netherlands around us. These are very important. And because of those solutions, some of the solutions, 8 of them, and 10 of them, mostly the most simple devices that we, the smallest and the most simple ones, we were able to develop further into a spin-off company and to bring it to the market. So everything went really well. But then, 5 years ago, someone cut some pages out of a women's magazine and put it in my postbox. And I still don't know who did it. but it was about women in Africa. Women who were sent away from their communities because they smell. And they smell because they were raped in a terrible way. They were not treated. So they got fistulas and all kinds of problems. And then because of that, they were sent away from their communities. And these stories touched me. For them, there was no surgery. And I started reading about it. And I discovered that the large part of the world did not have access to surgery. That about 5 billion people do not have access to safe surgery. And 2 billion people do not have access to surgery at all. And me working already for 25 years together with surgeons in a hospital, I did not know the impact of lack of safe surgery. I didn't know about it. And I know a lot of surgeons are going to these countries trying to help, also going to the rural areas. But I was wondering, where are the engineers? Where are the engineers trying to help? Trying to help those surgeons, bring them better equipment and better tools. I hardly could find them. I was amazed about it. So I thought, okay, what can you do? Well, we know there needs to be better infrastructure, better power supply, clean water, and better equipment. But also, we need affordable and high-quality devices, effective and affordable training systems. But also, we should not forget, we need also train biomedical engineers and biomeds, the biomedical equipment technicians. We need to train about 2 million surgeons and do to be done more efficiently. Like, for example, a company in the Netherlands is trying to make movies, animations, to train, put them online so that people can enroll also in rural areas and poor people can use it. Training equipment and training also the skills like laparoscopic procedures if you want to do minimally invasive surgery, because there's a lot of benefits in those countries as well. But there are more problems. Do you think about this? Waste, hospital waste. It's estimated that in some countries 50% of the diseases occur due to hospital waste. A lot of diseased, infected material is put on waste dumps. Including needles, and they are reused again. Can you imagine? Now, without going to these countries and knowing about these countries, you don't know what to do. So we have students going to those countries, doing internships, and then now come the question, can you build a needle cutter? So with some students, we built a needle cutter that before you dump it, dispose it, you cut the needle off. We could not think about that we need such a device. How to make that waste is collected in the right way, that infected material is autoclaved before it's disposed. You need you need to train people, make awareness about these kind of things. Also students working on improving the whole sterilization process. They only had one water place to clean. So clean and dirty was mixed. She was managing to have another one, so that it could be from dirty to clean process. Without thinking about this, that's now not how we clean our operating theater. Or putting a gauze around a tap. Learn people that is not making really water clean. Disposables. That should not be used, but it's done. And also there's a picture from an autoclave. They didn't dare to increase the temperature above 90 degrees because they were afraid that it would explode. And now students going to this hospital trying to set up the sterilization department there. I was asked when I started with this, I was asked to give a TEDx talk, and I thought in that moment, how could we scale up? And in the Netherlands, we have a famous beer brewery. They sell their beer everywhere in the world. They have factories everywhere in the world. They have people in the factories that are trained, and they have clean water, and they have power supply. How to do that? Can we not use those knowledge from those companies, and maybe also the food industry, Coca-Cola, those companies? How can they help not? Can we ask them to help to improve the infrastructure and also the logistics? to get spare parts over there. We have Coca-Cola everywhere. We have beer everywhere. Why not get also the medical equipment everywhere? Can we use their knowledge? But yeah, we also have to educate the biomedical engineers and the biomeds. And also to think about how to scale up that. You need kind of e-learning methods to do that, to scale up. But also we need to have user guides available. I had students going to Nepal, and what they did is they set up a training system how to train biomeds to use Google and Google's Translate to find manuals that you can use to prepare their equipment, to repair and maintain their equipment. But they also showed that a study at the Nick Simmons Institute that tried to improve the education of biomeds in Nepal. They did research on how many biomeds are needed and what the impact of biomeds are in hospital. And they could show that really the hospitals that have biomeds available, they have much more equipment also up and running, available, maintained. But also there's lack of spare parts. Can we solve that? And also they showed that also communication between the biomeds and the clinicians could be improved. And of course, maintenance is really lacking. Of course, if you don't have that set up, don't have the biomeds, and all the equipment that we donate a lot. I was amazed how much equipment we donate. But if we don't educate biomeds that can maintain them, then they end up here. And we have to develop affordable instruments and affordable solutions. And here you see an example that I found about the use of surgical drill. Very expensive. But this one is just bought at the local home improvement store. And they trying to cover it up. When I saw it doing, it was not really sterile. But the idea is good. They cover up with a hand glove. But I know there's also a company making a nice of sheet around it, a cover that you can use with this cheap, affordable drills. So there sometimes you can find nice solutions. Now, the first project that I started with was the electrical surgical device. Got funding for that. Very expensive device, cost between 10,000 and 50,000 euros. Now we try now to develop one for 1,000 euros. Because we looked into our hospitals to see how is this device used. And we saw it's only a few settings is used in practice. Now, why need all those settings if only a few are used? So we want to come with a more simple one. And also, what's very important is the spare parts. Now, to develop one, we went to the country to see how does the interface look like. This device is often carried around from one theater to another, so it should be portable, easily portable. But also the interface should be easy. And finally, the spare parts. As now are always disposable and already indicated, then it's difficult to get access to them. Can we not develop one reusable and also use 3D printing to make it? Or 3D printing might be a new technology that might be getting, also many countries get access to. Another example that we're working on, video laryngoscope. If you need an intubation and it's a difficult case, then you can use an expensive video laryngoscope about 10,000 euros. But why not using an endoscope like this? You can buy it for $10 on Alibaba.com or eBay.com. This kind of technology is available, but you need it in combination with, for example, 3D printed video laryngoscope. And we are now testing it and seeing how can we use it. And we're also testing it, what happens with this material if you put it in Sidex for sterilization? Does it maintain well enough? And these kind of tests are needed. And also we would like to do is bring minimally invasive surgery there. As I indicated, and it's many big advantages to do that, because then patients can get quickly home again, especially if they come from far and have to leave their families at home. We need a lot of equipment. But we worked on a new type of steerable devices, minimally invasive devices, and we found a way to make steerable devices very stiff, steerable, but also that you can disassemble them. And we came up with solutions with, instead of using cables, which is standard done, using two rotation tubes. And you can then get an instrument that can easily be disassembled and assembled again, as you can see here. Reusable, cleanable, very strong, and you can steer it, and you can even, it's strong that you can cut bone with it. We know that offhand the robotic, the Da Vinci robotic surgery, one of the biggest advantages is that you have an extra wrist. But it comes with a very expensive robotic system, but also very expensive tools like these. And also not really good, able to clean. We came up with this, if you can have a steerable principle with this rotating tube, instead of 2, you can also have 3. And if you have done 3, then you can steer it in all directions. And if you can steer it in all directions and you can clean it, you can also put a hand grip on it. Then you have the similar kind of function, but with much more affordable than these expensive robotic systems. And you see how the system then works. You have an extra wrist with a reusable, handheld tool. That is affordable. And especially because it's reusable, well, it might have a big impact. And we are now currently within the clinical trials to use this kind of instrumentation. And it's only, if you disassemble it, it's only 4 parts, the tip. So that's really easy to assemble again. But we need more. We work also on clip appliers, reusable clip appliers, and maybe even also with this wrist. Reusable sealing device. Yeah, and then also we want to have an affordable camera, endoscopic camera, preferably using consumer products. But when you have this tiny incision, why do you need a whole sterile operating theater? Is it not possible to cover up this incision and be able to work sterile? But you need to be able to exchange instruments. So we developed a connector system that you can do it. And this way you can work sterile without a sterile operating theater. And that might be a way that you can use it also in rural areas. You can carry everything around in a small suitcase and bring minimally invasive surgery also available in rural areas. So in conclusion, yeah, I hope I could make clear that really it's important to have more engineers working in this area. Engineers that should develop affordable and high-quality devices to bring surgery, but maybe also minimally invasive surgery, also in the low and middle-income countries. Thank you for your attention.
Thank you very much for that interesting talk.
So we'll be having the questions after, as previously mentioned. I'd like to take this opportunity to introduce our next speaker. Dr. Jasudian Ganaraj. Dr. Ganaraj Jasudian is a urologist and general surgeon who trained at the CMC Vellore with a passion for rural surgery. He started the Kukna tribal's development in the Dangs district and has since empowered more than 30 rural hospitals to start minimally invasive surgeries. He has over 300 publications and is currently the president of the Association of Rural Surgeons of India, a member of the board of directors of the G4 Alliance, joint secretary of the International Federation of Rural Surgeons, and adjunct professor in Karun University. In addition to this, he's the project lead for India of the NIHR GHRG project at the University of Leeds. He's currently working on devices and techniques like the gas insufflation, there's laparoscopic surgeries, and a laptop cystoscope to take modern surgery to the poor. Today, Dr. Ganaraj will be speaking on barriers faced by a rural surgeon in technology and examples of frugal innovation that have amplified surgery. Thanks.
Good morning. Well, starting, I need to make a confession. I just couldn't misplace the speech that Noel printed out. So I think by the time it's 20 minutes, I think he needs to literally pull me out. Anyway, I bring you greetings from the land of Jugaad innovations. If you look at the second picture on top, that was taken about a week ago. It's a mobile fruit shop powered by the motorcycle that you can see there. And if I told you that surgery brought down the infant mortality rate from more 400 to less than 100 within a year, please don't misunderstand me. Because the surgery I've been talking about is the closure of a duodenal ulcer perforation. You may be wondering how that has anything to do with infant mortality rate. But it's only after doing the surgery, people started listening to us and following our advice. Till then, we are nobody, even though we trained from the most premier medical institution in our country. And then when I started my career in a mission hospital in Maharashtra, we had to make a choice. Our power supply would allow either the suction or the light. So what do? It's a difficult question to, I mean, sometimes it's quite difficult to choose. So the solution we came up with that, we started operating in open air. We used excellent sunlight which God gave us and used the suction from the electricity that power could generate. And then right from the beginning, more than 3 decades ago, we realized the most efficient way of delivering surgical care is that you go and conduct what we call as diagnostic camps. Because more than 70 to 80% of the patients in the rural areas, they don't know they have a surgical condition that can be treated with the surgery. So unless we do ultrasound, we won't know whether they have a gallstones or kidney stones which cause the trouble or pain. And we had to use a lot of innovations. If you notice that we have laptop computers, softwares, the televisions, then in fact the first 5,000 laparoscopic surgeries we did with ether and EMO machine. And I was surprised that many of the anesthesiologists also have not heard of ether and EMO machine. They say it's a historical interest. But we were using it for the first 5,000 laparoscopic surgery that we did. And this place, again, a place we recently went for a diagnostic camp, involved about 18 hours of drive and 10 hours climb steep uphill. And we had to have about 22 porters to carry our equipment. Now, I'm sure you can't expect running water, electricity, and those sort of things in those areas. But there are about 4,000 people there. And thanks to the technology and the help from our engineers, we were able to do things like double J stenting, cystoscopies, and all those things in those areas. And the innovations, not only medical devices, quite a few of them have to do with non-medical things. Just a simple fact is that people in rural areas, they do not have money. So what do? How do they pay for our services? Because nobody gives us money to just go and serve people. So we started insurance programs and various other programs with the local grocery shops. There are not much overheads involved in these sort of insurance programs. And they know how to take the money from the local people. And they are quite honest in paying us for the money that we need for the surgeries. Then we worked out to the churches in Mizoram. They gave them the piglets, which they grew and sold and came with the money for elective surgeries. And of course, we had to do a lot of modifications to make surgery available for them. Because as a urologist, I had a cystoscope. So the first diagnostic laparoscopies and the small procedures we did was using the cystoscope. And we could do insufflation with the BP cuff and so on. And Dr. David Jane was talking about the mosquito net being used instead of proline mesh. And these innovations came from the Association of Rural Surgeons of India, the conferences, which have been going on for more than 25 years now. And I don't want to go through the details, but you get a lot of frugal or jugaad innovations being presented in these conferences. So anyone interested in learning about jugaad innovations, you are welcome to attend the conference of the Rural Surgeons of India. It'll be in remote places, not good facilities, but then you learn quite a bit about frugal innovations. These are some more innovations that probably can have a look at. Again, don't want to go into the details, but of course you saw one ventilator here. This ventilator on top can run on electricity, compressed air, or mechanical, or you can have a cycle which you can attach to the thing to operate the ventilator. So whether you have electricity or not, you can actually do these procedures. And then, of course, you can see a lot of training equipment, which again the rural surgeons use. And one of the interesting things is that when we all know that laparoscopic surgeries are very relevant for the rural population because they don't have to stay for a long time and they can get back to work and so on. But then it is, you don't realize the logistic nightmare of getting these CO2 cylinders to the rural areas. In the first place where we started, we had to get it from 500 kilometers away to get a few cylinders of carbon dioxide. So we started with insufflation with air when we ran out of carbon dioxide. Then we started using the dental compressor that we had for producing the air. Then some places didn't have all these, so we had to use the oxygen cylinders. And then we also went to the extent of using the nitrous oxide from the anesthesia machine. So we used all sorts of things for insufflation. And of course, the Western countries don't approve of anything other than the carbon dioxide. So now we have done away totally with the insufflation. We have gone on to gasless surgeries. And as Professor Dunkelman said, we want to be really friends with the engineering team because they can really help us quite a bit. One of the things we are struggling with rural areas is people with renal failure. Only option they could really have was peritoneal dialysis. And Baxter was telling these catheters for 14,000 rupees. So, and which is quite a bit because patients can afford maximum to pay about 10,000 rupees for the entire hospital stay and surgery and so on. And if you use a catheter costing 14,000, it's very difficult. So then we went to these engineers and asked them, can they make a catheter like this? They said, how many thousands you want? I said, no, you want only 5 or 10. And they said, oh, then it's going to be expensive. He said, doesn't matter anyway, how expensive? They said, it'll cost 600 rupees. I said, what? Where is 14,000, where is 600? They said, if you order at least 100, we'll give it to for 150 rupees, 180 rupees. But only 10 means only 600 rupees. We said, fine, but can you make an additional change? Because Baxter's catheter gets blocked often because momentum and gets stuck onto it. So you want a catheter with memory, which you can pass a stillet once in a while to release these additions. They said, that's not a problem. So we got these catheters made for 600 rupees. And there are a lot of other things, low cost endolobes and non-invasive blood sugar. I'm a diabetic, so I don't like being poked. So I worked quite hard on this. And it is working. And we are done with quite a lot of these innovations, which when you have time, we can discuss later. Of course, these again we already talked. So we did, as I mentioned earlier, we started doing laparoscopies with the cystoscope because that's a scope that we already had with us. And we were able to do quite a lot of those. And then what we did was we started applying those principles to open surgeries. So we realized that gravity was a great friend of ours. because we can change the position of the patient. We have a steep head up, the intestines fall down, or steep head down for pelvic surgery and so on. So we could get away with the much smaller incisions even for open surgery. And the other reasons big surgeons make big incision was the light was on top. And we wanted quite a bit of good lighting there in the operative field. So if you use the cord light that we use for cystoscopes, we can have the lighting right at the place that we want. So we started actually doing all these things to applying to open surgeries. And then, of course, the laparoscopy, one of the great problems is that disposables are very expensive. Of course, we can reuse a lot of things. But the first Apple Trocaro, the port that we had, we used for 532 times before we could not use it anymore. But then staplers and other things we can't reuse. So what we did was we did all the dissection, everything laparoscopically. Then made a small muscle splitting incision to do the anastomosis. And then, of course, being a urologist, we had many non-urology uses for a ureterorenoscope, for the CBD stones and whatever you name it, we could use it for fistula and so on. But as a urologist, what I'm really happy about is that we had a lot of patients with renal stones. In fact, in Uttarakhand, one of the areas near Himalayan mountains, 4% of the population at any given time have kidney stones or urinary tract stones, which is a very high number because India is a very thickly populated place. And the currently available treatment methods, whether it's open surgery or PCNL or ESWL, are either very expensive or require general anesthesia. General anesthesia is something very, very precious and difficult in rural areas. We try and do everything under spinal anesthesia. So we devised a method of prayer DJ stenting and removing the stones with the ureterorenoscope. And this worked. We have done more than 3,000 to 4,000 such procedures now. And one of the requirements was that it has to be done in several stages. First they come and put in a stent. Then 6 weeks later we need to do the first URS and break the stones. Then again put in a stent, and then they have to come for removal. So if the local doctor is able to take over the stenting and so on, it's much easier. But then they need the entire setup. The telescope is expensive, the light source is expensive, we need power and so on. So we designed this new cystoscope, which can be just connected to the laptop computer. And we can do the scoping, because all you need is a camera. We don't need a telescope. And the only problem is that it takes, because it autofocuses, it takes a little while, a few seconds to focus. But it doesn't matter for minor procedure like stenting or diagnosis. So this dramatically cuts down the cost. And I'm sure I had a little training from Harvard University Business School. They'll be very happy about TDABC or time-driven activity-based costing and so on. But the bottom line is that our method will cost only treating the entire load of patients in Uttarakhand about 1.3 million rupees, while the standard one, excluding the travel and so on, will cost 36 million. So it brings down the cost to 1/36 or so on. And this is something which probably the gynecologists allow. This is a special type of stirrups with 2 ball and socket joints, which you can use for positioning under the drapes. So once you drape, it's very difficult to change the position. But this makes it possible. Just one click lock is there, and we needed this for the ureterorenoscope. Okay, I think there's only a few more minutes, so I think I'll rush through some of these. Just one more minute. Okay, so one of the things, actually, this picture again, no, not this. I think the order is, this picture again is taken just 2 days before I came, the one on the right. Here again, what do we do when we have low calyceal stone? again have the patient head down and tilt. And the gravity, as I said earlier, helps us quite a bit in these also. And the final thing which we are really happy about is that the gasless surgeries. Laparoscopic surgeries are very relevant. And it's very difficult and expensive because of the logistic problems involved with the gases primarily. So if we do away without gas, then it makes everything easy. We can do it under spinal anesthesia. We don't need expensive equipment. We don't need specialized equipment. Even learning curve for older generation people is easier because we are used to open surgeries. And this is the equipment that we designed. I don't want to go into the details now, but just give a list of advantages. It has a great advantage. And of course, people generally don't talk about disadvantages. But the only problem we have right now is that we need to have a BMI of less than 28. Yeah. But then the advantage is that you can do most of the surgeries with single incision in the umbilicus, which you can't, it's a hardly visible scar after it heals. And we sincerely thank the NIHR GHRG project for supporting the validation, training, and the various other support they are giving us in conducting the things. So finally, what are the take-home messages that you need to learn when you go out? See, right now what we realize is that most of the research are driven by industry, which makes each generation of instruments more and more expensive. But on the other hand, what we need is to research to bring down the cost to the people. So unless there are some academic institutions and others who are interested in funding specific research for directed to rural areas, the costs only keep escalating. And things like gasless surgeries and the surgery that we do for kidney stones. Okay, thank you. I'll stop.
Thank you very much. Thank you very much, Dr. Hamish. Okay, thank you. Can I invite Rosie Amodi, Rashida Patel and Charisma Sharma to the stage if they aren't behind me already? And just a reminder that we're encouraging you to download our app, the Network app. And then if you download the app and search for Gasoc, you'll find the conference there and the way to interact with everyone. And there is the facility to post questions on the Network app. So let's see that being used throughout the day, and our friends in Rwanda will hopefully be using that also. So we're delighted to have so many organisations supporting us today. As we've referenced, there are stalls in the bar area above and the Millennium Room below, and we'd be delighted if you interact with all of them. So we have a presentation ready now from Lifebox, one of the organisations represented, and I'll let them introduce themselves. Thank you.
So, hi everyone, thank you so much for having us today. So we are Lifebox, the leading non-profit organisation addressing the fastest growing global health crisis today, unsafe surgery and anaesthesia. So our organisation was founded in 2011 by surgeon and author Dr. Atul Gawande, along with other leading medical professionals. The Association of Anaesthetists, the Brigham and Women's Hospital, the Harvard T.H. Chan School of Public Health, and the WFSA. With a robust monitoring and evaluation system, we work closely with many partners to provide tools and training to surgical teams in low-resource settings and to improve anaesthesia safety, reduce surgical infections, and to strengthen teamwork in operating rooms. So I'm sure you've heard of the checklist and other things like that. So Lifebox are responsible for that.
So Lifebox have a flagship program, and this has developed a low-cost and low-resource adapted pulse oximeter for monitoring patients during anaesthesia. 20,000 have been distributed in providers across 100 countries, And also in 2016, we piloted Clean Cut, which is a quality improvement program in Ethiopia that aims to reduce surgical site infections. Our first 5 sites to implement the program have seen a 30% reduction in surgical site infection rates as well. So Lifebox counts on the support of healthcare workers across the world, and please come to by our booth on level 2, and just to see how you can get involved with our work. And thank you, everyone.
Yep, and we're very active on social media, so do follow us, please. Thank you.
Excellent. So good to see Lifebox students here. Thank you very much for that. We've got a video from RCS about their work in global surgery. So we're just going to get that on. Just need to turn the... Okay, we've got some technical issues here, so we are just going to invite the panel up of our speakers and have a Q&A session. So can I just invite the panel, please?
Yeah. So if Professor Jane, Professor Dankelman and Dr. Ganraj wouldn't mind coming back up, we're going to invite questions then, just while we're getting this sorted. Yeah. And obviously, so that our colleagues elsewhere in the world can hear your question, we'd be grateful if you would raise your hand and wait till the microphone is brought to you. Briefly introduce yourself and then put your question to the panel. So, does anyone want to start from here in the hall? Anyone want to start from here in the hall? With a question from the talks we've heard so far. Okay. Sorry. Yes. Okay, great. Can we have a microphone over there? Thanks very much. And the panel are, of course, welcome to interact and disagree amongst themselves or agree, as the case may be. Okay, sir.
Good morning. My name is Daniel Lojuka from Kenya. Thank you for the various presentations that you've done on the innovations. I think my question would be on the issue of mosquito nets as a mesh. I think the initial thought that I had about this were that probably is a very good innovation, but I don't know whether any of you have had an experience with the patients who have had this kind of surgery, because I think the outcomes that I hear later on, because of the weight and the amount of reaction that it causes, I think majority of the hernia surgeons would think twice about it. So probably my question is, have you ever had an experience with it? What are the outcomes of the surgeries that you've seen done with it? And probably just to think that even as we think about innovations in the low and middle income countries, there should be probably innovations that bring same qualities of outcomes as seen in the first world. Thank you.
Thank you very much, Daniel. Dr. Ganraj, do you want to begin answering that then? Thank you.
See, the mesh material is exactly the same. There's no difference between Prolene or the mosquito net. The difference comes only in how we sterilize it. And some of the places we just autoclave it or put it inside eggs and use it. Then obviously the chances of infection are higher. But if it is properly gas sterilized, there are a lot of multi-center studies which show that there is absolutely no significant difference. And I mean, whether you use regular Prolene mesh or mosquito net mesh, there will be some people who obviously do have infection and have this thing. But this is not statistically significant if proper gas sterilized mesh is used.
So I think that's the key point, isn't it? It's all well and good having an intervention, but it's much more than that, isn't it? So there are randomised controls, reasonably good quality trials that show, it works as well. But it's not just the mesh, isn't it? It's the quality of the surgery. It's the sterilisation. It's the whole package. So you may have a mesh. If the quality of surgery is poor, the outcomes are going to be poor. But the key point is whatever you do, you have to put the evaluation around it. Otherwise, we'll never learn, and bad practice will just continue. So it's about pulling together not just an innovation, it's the whole package to provide the optimum environment for it potentially to succeed.
Yeah, surgery is a very complex, interdependent system, isn't it? Can I try to see whether we can manage to get a question from our colleagues in Rwanda? Are you able to speak to us? Hello, Joseph. Right, things are coming and going, so we may end up picking it electronically. I don't know if your mic is muted, Joseph. You might want to make sure. Anyway, any other questions in the room as we're waiting? Yes, sir. Can we have a microphone there? Thanks. Microphone down there.
Yeah.
Thank you.
Thanks very much for all of your fantastic talks. I was just drawn to thinking about how when we think of global health, most of the focus over the last 20, 30 years has been on infectious diseases, maternal, child health. How do we begin to advocate for global surgery within that global community?
If I may comment on that, I think already a lot of things have been done, but there are some problems there. I think we should make the world aware that more people die because of lack of safe surgery than on infection diseases. About 4 times more people die because of lack of safe surgery. I think it's about 17 million people per year. It's the same amount as people that live in the Netherlands. It's really amazed about a high number. But yeah, the awareness campaigns, and also if you look at the pharmacy, maybe we should learn from the pharmacy how they do it. Because at least in the Netherlands, there's much more attention to infection disease than on the lack of safe surgery. And I don't know exactly how to do that, but we need to make the awareness campaign about that. Much more attention should be paid to this as well, and also to have a lot of people working on this in this field, trying to bring, what I already explained, get more engineers working in this area, try to develop affordable solutions. But there's much more needed than that. Also, from the medical side, I think we also, the training all those surgeons, how to skill that up and how to make an awareness campaign. I think we need some people that are good in marketing and doing things, involved in our projects and involved in our organizations to make clear to the rest of the world.
Thank you very much, Prof. We'll try again from Rwanda. Joseph, do you want to let us know if you have any questions for the panel or any comments, indeed, on what's been said?
Sam, can you hear us?
Yes, we can. We can hear you. Do you have any questions or comments?
Very good present. Yes, we have some. One question is to all of the panel, how to balance ethics and also innovation. Because sometimes you may bring things which you can not use in high income user, you bring them in LMICs, how to balance that. And another thing, someone said also about pain and also doctors, health care providers. The challenge is the education.
Okay, we certainly caught the first of your questions there, Joseph, which was around the ethics of innovation and making sure that although we're trying new things, we're not unfairly and wrongly disadvantaging people by maybe putting them at risk of complication. So how do we balance that importance of innovation with that need for quality assurance and doing no harm in the first instance? The panel want to comment.
I think it's a very important question. My opinion is that we should stick to the rules that we also use in our countries. And when developing devices, we should go through the same procedure. I know it's a long and difficult part, but I think we should do that. We should take the similar kind of procedures, similar kind of tests and experiments and CE mark kind of things.
So there needs to be some form of regulation.
I know that takes a little more time, but in the end, I think it's the only way that we should do it. Sure. That's my opinion. I know my colleague has already different.
So another opinion.
Even 2 days ago, we were fighting over the thing. Like even simple things like registry and recording. I don't understand why we need an ethics committee clearance for it and so on. And again, in countries, LMICs, there's hardly any ethics committee and only few are there. To get their approval will take a long time. But then unless you do it, then we cannot recommend it worldwide or it's not valid.
You're saying it's maybe applicable in your local context to do it that way, Dr. Ganaraj. Yeah. Comment from Prof. Jain, and then maybe a brief comment from Joseph.
So, I think it's absolutely true. You know, every country will have their own cultural interpretation of what is socially acceptable and morally right. I think there is a degree of insurance around this because when we want to do anything, there is in effect a dual ethics submission. You have to submit to your own country, so it has to comply with your own country, and that's key. But then you also have the in-country submission as well. So there is a degree of insurance. I admit it's not totally watertight, and I guess ultimately what we need to strive for is some sort of unified, WHO sort of guidance on it, really.
See, another thing probably we should have is the interaction between the ethics committee in the Western world and in the LMICs. Because a lot of times the Western world might not understand the cultural issues. For example, consents, informed consents. The patients hardly have any say in it. It's the head of the family who decides. And whatever the patient wants, if the head of the family wants something else, it's very difficult to have what the patient wants.
Can I come back to Joseph?
So the consent actually is more relevant from the head of the family than the actual patient himself in some other societies.
Thank you very much. Joseph, do you have a comment on that before we move on? We're not hearing you just yet.
Not much comments.
That's great. Fine. Okay, thank you. Thank you very much, panel. Could we thank them now? Thank you. And please do interact on the network app and be tweeting. Please be interacting. The value of coming to a conference is all of us, you know. You can listen to content online, but so much of the value is the interaction. So please make use of the time for networking. I think we're going to have another try to view the video from RCS England now. And once we've done that, we'll move on. We're going to try again.
Okay, we've got some tech issues with the video, so we'll show the video in the afternoon.
Okay. I'll let you introduce the next item then.
Yeah. We've got the WHO head of the medical devices who is live streaming, who I'm going to try and get on the live stream. In the meantime, Ollie, who is our media rep, is going to get a poll up, and we would want you to go on your apps, the network app, and start polling. Okay.
How about you start introduce this next speaker?
Okay, so we'll introduce the next speaker, who we're just trying to get the live stream working for. So her name is Miss Adriana Velázquez Berumen. She's a Mexican biomedical engineer who works with the WHO. She's the coordinator of medical devices for the WHO. She's responsible for the Compendium of Innovative Technologies for Low Resource Settings and Medical Devices Technical Series books, among other WHO projects. Today she'll be speaking on the importance of technology in global surgery, specifically focusing on health technology assessment and universal health coverage. Afterwards, we'll have a chance for some questions as well.
Yeah. Noel, do you want us to ask questions as we're waiting in the audience, or?
No, I think we are almost there.
You're nearly there. Okay. Thanks for your patience, everyone. So many elements of technology that we're trying to get to work today, so thanks for being with us.
And just while that's going, just a comment in addition to this gentleman's question or statement about improving advocacy and improving access. I think it's important for all of us here to recognise that we are advocates. By coming to this conference, we are advocates for global surgery, and it's our responsibility to go back to our various institutions and spread the word and begin to do it even on a lower scale. And then, you know, if everybody here impacts 10, 20 people after this project, that is advocacy. And one day we will get to where we're hoping to get to, but starting small scale and then building it up.
Yeah. Thank you.
So for those of you who haven't already interacted with our Facebook or Twitter or Instagram, we have a Slido question page which you can contribute questions to, and we will be having our live polls on that page as well. So I think that link is being posted on our social media sites, Twitter, Instagram, our Facebook. Please do go on that, and then you can post questions onto that, which we'll read out during the day, and people can also review, and you can link up with those people throughout the day, and we'll also be having our live polls. So if you put up the page, what it looks like. So we're going to put out the page so you see what it looks like. It's basically a web link that you go on, and you can contribute your own questions that you may have that you may not necessarily want to, or may not be necessarily related to the talks, might be just generally about your experience with global medtech, and you might want to ask some questions to those in the audience. So that's what it looks like. So you can type your question along with your name, and ask questions of the audience. People can respond back, and there will be also some polls which we'll be doing later on in the day. Thank you.
Thanks, Ollie. So we'll work on sending out that specific link on social media. So the Twitter handle for Gasoc is @Gasoc_2015, if you haven't followed us already. Maybe I'll just ask a question of Prof. Dankelman while we're waiting. I was really interested in your plea for more biomedical engineers. I'll maybe just get Delphine there to hand you the mic. Thank you very much. We've focused a lot as surgeons, anaesthetists, obstetricians on trying to upskill and upscale training for medical professionals, but do you have any idea of what the gap might be in terms of biomedical engineers in low and middle income country settings? I don't know if we could have that mic on. Sorry, I think it is on.
It's on? Yeah.
Yeah, there we go.
Yeah, I think it's a very good question because we really don't know. And that's why we started also first investigation in what is the role of biomedical engineers and how many biomeds are available in hospitals. We did it in Kenya and in Nepal to find out what is the situation, and also for us to see what do we need to do if we want to try to help them. So we saw some hospitals that some have, but also some hospitals do not have any. So we already did a short investigation on that. We will publish that shortly. And we also saw that we could, by looking at all the problems that we figured in, we looked in all kind. They have they report all the problems with equipment in the hospital on paper. So we looked in all those papers and collect all the papers from a number of hospitals to see what are the incidents and problems that occur with equipment. To see also what kind of equipment are most vulnerable. And need all those kind of solutions. Mm-hmm. So, and also that we collected from, I think, about 15 hospitals in Kenya and a few in Nepal. And that gives us already an idea about where do we focus on new type of devices, devices that fit the context, but also what do the biomeds need? What for training do they need? Now we started then with a one-day course on how to use Google, but what we also did is to show to them. We had students going there and they just show how to open up an operating table just to be able to clean them. They never did. So they open up and they find all kind of difficult dirty stuff in that. Another example was a holder from a microscope that was not doing the job. Just show them how to open it up. And very quickly they can find the problem and solve it. But they somehow need to have those a tool. And I think what you can do online is make a simple movie. Just on YouTube, if you want to repair something yourself, you can just Google it and you find a movie example. Yeah, everybody is doing it.
YouTube to remind myself.
Everybody is doing that. So
why not? Yep.
Why not trying to, for all the equipment, have the simple movies online available for everyone? How to maintain and repair. I think maybe that is the most simple solution that we could try to.
That's really interesting, isn't it? And that's maybe something that people could get involved in many locations in the world. Interesting. How are we getting on, Noel? Do we have some time for more questions? Or are you nearly ready?
Time for more questions.
Time for more questions.
Questions on slide.
So, where were the ladies from Lifebox? Are they still in the audience somewhere? Okay. Right. Okay. We've got some questions coming up on Slido. So I suspect you've not really all got the link yet for that. So there's an interesting question here from Anonymous, who asks, what resistance has been met from biomeds companies who are driving up costs of medical care in high-income countries? So any comments on that from anyone? Dr. Ganraj has an opinion. Anyone else with an opinion?
See, I can give you a couple of examples. I went to Karl Stoff's company in Germany. We were talking about the rural areas and how to reduce the cost and so on. The blunt reply I got is, we are business people, we are not interested in rural areas. No more.
Okay. Can I just check, is everyone hearing? Is the microphone on? Yeah.
Then we worked, actually the company called Medtronic was very much interested in the gasless device. So they spent about 1.5 years investigating it. They collected almost 2,000 pages of information and various studies and so on. And their target was that next 15 years, they need to achieve a certain amount of income from it. And when it actually we tried to getting them business and saying that only 10% of people are doing laparoscopic surgery, 90% still do open surgery and so on. So they listened to everything, they evaluated, they did a lot of studies and said that they'll meet only 80% of the target. So they decided to stop everything.
Stop funding.
So a lot of these things are driven, commercial people, it's the target and money.
Yeah.
So that is the reason why we need more academic people and others to get involved.
So academia has a role in...
so that we can cut down the cost for the poor
for
people.
development and so on. Noel, just you interrupt when you're ready, but do you have some more questions that you've picked up in the app there, Ori?
So we have a question. Well, the next question is relative to what you've said. How do we keep the cost of innovative technology down so that new devices can be kept affordable for LMICs?
But with academia, there's a risk that still corporate companies can get involved in financing that. So is there any other way of keeping those costs low?
I mean, again, see, one of the main issues of contention with us and Medtronic was that right now they make 30% of the profit from the disposable ports.
Sure.
And they wanted us to use ports for the gasless surgeries, which I say doesn't make any sense. So because we have openly no need for no gas leak and this and that, and it's far more convenient not to use a port. But if we had used a port, added a port, they would have achieved the target. So I don't know whether, we need to make some sort of compromise or whatever it is. And again, the proper studies and evaluation is expensive. See, when we designed the gasless equipment, we had to get the money for it from the patients who are paying. And our patients, if they pay more than 10 to 15,000 rupees, they go below poverty.
Yeah.
So we can't increase the cost. So from first prototype to second prototype, it takes a long time for us to sort of develop the next one.
Yes.
So that period can be shortened. And now, because University of Leeds and the project is involved, be able to cut down the period. And then evaluation again is expensive. But then unless you do that, you can't publish it, you can't recommend it, all those things.
So,
nobody listens to some publication from Rural Surgery Journal or whatever it is. But same thing if it comes from BMJ or Lancet or something, is well accepted.
Yeah, thank you very much. I think Prof. Dankelman had a point. Can I just check that we are hearing through the microphone okay? Is that working?
Yeah, I think so.
Yeah, that's fine. And anyone else who has a point, just raise your hand. Thank you.
Two things to add. I think we should develop more reusables. Focus on that, try to find other solutions, because for the companies, the disposables are really beneficial only for the companies. The reusables. And another thing is could be thinking about 3D printing. 3D printing solutions could make a lot of devices maybe more affordable. We did some first initial tests to see what happens if you put them inside with the material, but also the strength tests and that kind of thing. So if you we need to also do a kind of certification process after that, but that could be a solution to bring all kind of spare parts local producible. Because we see already now 3D printing small companies also in the lower middle income countries coming up, so that might be a solution as well.
It's interesting, 3D printing. Yes, thank you, sir. Let's pass the microphone up. And
One experience that we've had with vac sponges is that there are a lot of neat innovations with vac sponges around the world. And what happens is the big companies buy up those smaller companies, and those products then disappear forever.
Right.
So I think one of the challenges is about, and especially with universities and with IPR and innovation, how do you ensure that if you develop a new innovation within a university, that you then don't sell that company off to one of the bigger ones?
How do you protect
how do you protect your IP, and how do you retain it within the university?
Interesting. Okay. Do you want to give a view on that, Prof?
Yeah, well, I think you have a very important comment or remark there, because indeed we have to really, but that means that the company, also the small company, really should be motivated to work for the lower middle income countries and not wanted to sell. And also universities should play a role in that. So it should be about the social impact and not only economic impact. And that's something that we have to learn, and also a university have to learn about that.
Thank you very much.
Interesting. I think we had one more comment. Are we ready? No?
Not quite.
I think so.
No. Thank you very much.
No,
you might need to just press that on. Yeah, there we go. Thank you.
My name is Alliance Nyukuri from Burundi. Just wanted to commend Professor here because my whole training, 5 years in general surgery, I trained with laparoscopy just using air. And there was always the challenge that the standard of care in the literature says otherwise, but using air. So it's a challenge to know how to ethically confront these standard of care, but it's very impressive to hear that you're doing so. How do you bring about innovation yet the standard of care, and how do you justify without looking as though you are indulging into malpractice? On a secondary level there's a mention of developing these cheap devices for LMICs, but reverse innovation, do you need them to make your healthcare systems even cheaper, and would that drive even more probably interest from the government to protect those innovations from the LMICs? Thank you.
Interesting. Okay.
Actually, to answer your first question,
just hold it straight up to your mouth, Dr. Garnish.
To answer the first question, when we started laparoscopic surgeries, we had only a nurse anesthetist who was very comfortable giving anesthesia with the ether and EMO machine. But then we searched all over the internet and talked to many people, or professors, everything. And no one has done laparoscopic surgery under ether and EMO machine. So then we had to pull out old Boyle's machine which was there, and we had to invite anesthesiologists from elsewhere when we started laparoscopic surgeries. And of course, he's not used to the machine. So the patient's oxygen saturation started at 100, dropped to 70, 65, and so on. That is with the Boyles and anesthesiologist giving anesthesia. Then we had no other choice but to shift to ether and EMO and nurse anesthetist, and it went up to the 90s. Then we continued the surgeries. But then, of course, the problem is that when you use air and ether, you're worried about fire hazard. So we had to take special precautions that we had one port where we had saline ready, and we used as low setting as possible. And we were very cautious about using electrocautery machine initially. And slowly we sort of learn how to do the thing. So when you do something first, you need to do a lot of background work to find out what are the complications, and if at all they happen, how to prevent it, and weigh against the benefits. If the complications are too much and the benefits are not much, there's not really no point in going ahead. So it involves initially a lot of hard work, and then the next important thing is that once you publish it, because we published it in Tropical Doctor, then I had a mail from so many people, thank you for saying that it is possible under ether and EMO, because we have been wanting to do it, and since you have published it, we are able to do it. So all these things are considered actually unnecessary because you already have overworked in a mission hospital or a rural hospital. To additional doing these literature research and publication and all that is extra work which you can comfortably do without. And it doesn't give you any academic benefits. See, the other thing is, again, IPR. See, we developed a low-cost vacuum therapy unit for diabetic foot. And I said, I'm not interested in money, so I don't need the IPR or I don't need to patent. But then somebody else used the same thing, and they patented it, and they made the cost 10 times more.
Yeah.
So now the benefit actually doesn't go to the patients.
So there is some value in
so
protecting that IP.
After that, we started applying for patents.
But that's presumably an expensive process. There are a few more questions from the apps.
So we have a question from somebody called Emma, asking what's the best way for surgeons and similar medical colleagues to link up with engineers or technology developers in order to bring their innovation to life.
Any engineers in the audience who want to answer that one? What's the best way for us to work
to get in touch with you.
We've got a view up there, and we've got a view from Tim. So first we'll hear from Tim, and then we'll hear from you, sir. Thank you. Okay.
I think I'm Tim Beaker from Medical Aid International, talking after a lunch, but I think the key thing in all of this, and in terms of doing development, is it's all about relationships, which is kind of life in general, isn't it? So the fact that you're even here kind of indicates you've got the right attitude, but it's if you work with people, you network and you communicate well and get people on board, then you can make things happen. And I think it's really important, and I'm going to touch on this later on, that we don't think of, if you like, industry as bad people. You know, they have to create funds, often which are reinvested into projects, but you do have to find the right people, and then you can do great innovation. We're in Leeds, and there's a great operating theatre company here, and I've done loads of innovation work with them. So my point is, it's about relationships, and it's about asking, and not making assumptions really that they are bad guys, if you like, because they're not. And many of them have done great stuff, and they're just as up for helping people as you are, but they've also just got to look at their kind of bank balance. So it's relationships is what I'm saying.
Okay.
And yeah, there you go.
Great. Can I just ask for an update there?
Yeah. Thank you so much for your patience, everyone, and thank you to Noel for his amazing, speedy technology work. We've managed to find an alternative platform. Noel is very happy to introduce our speaker, but I'm really pleased we got that opportunity for discussion. I think that was great to hear what all of you had to say. So we will be slightly later starting for lunch, but I think you'd all really benefit from hearing this talk anyway, so we're going to crack on.
Thank you very much. Ms. Berryman, can you hear us?
Yes, I can hear you well. Can you hear me?
Oh, so good to hear your voice from WHO Geneva. So there are about 150 people here listening to you. Can you get the PowerPoint on your... Yeah, I can see that you're trying to get the PowerPoint on.
Okay, it is there.
Excellent. So your PowerPoint is now on. And I just need to get the screen now.
Okay.
Just one sec. And we can see you as well.
Okay.
So.
But I think I'm listening to your transmission, to your live transmission. So let me.
So there is a group in Rwanda. We've got about 15 people in Rwanda who are watching your presentation as well. And we've got about 100 people here. So we are very glad that you have spent some time and decided to come and speak at this conference. So over to you. Thank you very much.
Thank you very much. Good afternoon, everybody. And I'm really sorry for this technological problem. But I was listening very attentive to all your previous speeches. I've been listening to at least the 3 or 4 previous speakers, and so I can address some of the issues that you were commenting. So first of all, I would like to tell you that, let me just find the best way to... Okay, the main thing. Medical devices are indispensable for healthcare provision. We all know that. They can help save lives and provide timely diagnostics and treatments, including, of course, surgery. But now we are in the 21st century, and still many have no access to them, not even the most basic. So the main issue of what I want to do today is we all can help. Each one of us can do something. So what is your role, and how can you help us? As you all know, the Sustainable Development Goals were released in 2017. And then we have number 3, that is on good health and well-being. But we also have industry and innovation. We have to reduce inequalities, etc. So what we are going to see here is that we need medical devices to assist, to prevent, diagnose, treat, palliate, or assist in any of the Sustainable Development Goals settings, in maternal mortality, newborn, communicable diseases, non-communicable diseases, etc. So they are everywhere, and they are needed everywhere to get the target. But they are mostly overseen. So there's a lot of emphasis in vaccines, there's a lot of emphasis on medicines, but not the emphasis we would like to have on medical devices, especially in medical technologies. What is the big challenge? When we talk about good health and well-being, our big challenge is that we need to have a target population. We have interventions that we have to do to these populations, and then we have costs related to these interventions. But every of these interventions, as you all very well know, requires a human resource or health workforce, requires guidelines, requires medical technology, requires medicines, and requires infrastructure, and then information to keep all that informed. And then when each one of them is missing, you cannot really perform that intervention, in this case, surgery. So we will want to address the issues concerning medical devices for surgery. For many of you, many would say, well, we're not sure what medical devices include or not. Well, it is one of the health technologies. It includes all medical equipment, all single-use medical devices, all surgical instruments, reactives, implantable like pacemakers, medical software, in vitro diagnostics. So all of these are under medical devices, and they are part of health technologies. Other health technologies are medicines or assistive devices, etc. Some of the assistive devices are also medical devices. And we have a huge problem. The size of the problem is we have 5 billion people lacking access to safe and affordable surgery, as you know from the Lancet Commission on Global Surgery, and this is the document in the WHO website. And when you get my presentation, you can open these links and then you will find all these documents. But the need is really absolutely immense. So what do we want to do? What we wanted to do is have access to medical devices, from policies to well-being. So we have to have a policy on medical devices, policy in human resources for medical devices. That is exactly biomedical engineers, which was addressed a few minutes ago. We need financial resources. We need technological development and industry, like the doctor was talking about innovation, but we need that innovation to be sustainable. We need knowledge and information. And then on the process side, all these innovations that we were just listening before, they come here in this red block. It is about innovation. But then we need to be regulated. We need to ensure, and I was listening to the question from Rwanda about the ethics and the regulatory approval. We need some kind of quality assurance to make sure that that device is good and affordable and good. And then we need to do assessment by national committees or the national procurement agencies, etc. And then we need to be managed by people that do the selection, the procurement, the installation. When we talk about innovation, but we don't talk about the rest of the thing, something that I would like you to remember, that for every device that we have, we would like that it is of good quality, safe and effective, but then the 5 A's: affordable, appropriate, accessible, available, acceptable to the user, affordable to the user, etc. So if we don't have these 5 A's, we will not make it, even if we continue to innovate. What will be the outcome? The outcome is that we really need to increase the quality of life. We need to save some lives, but we need to make people independent so that they can have the better quality of life. We have the economic development of the industry, and then of all of us, we can make the attainment of the highest level of health. So in WHO, we have produced the WHO Medical Device Technical Series. I don't know if you know it, but we have a book that calls How to Develop Policies. We have the Global Atlas that tells us what is happening in every country. We have the book on human resources for medical devices, and this is a question that was just discussed a few minutes ago, that they didn't know where are the biomedical engineers and if they have it or not in hospitals. A lot of information is here. We have country profiles, we have the country universities, we have the society professionals, and we know how many they exist. And we have about 800,000 now in the world. Then this is the part on innovation, the regulation, the selection of the medical devices that are needed for the health interventions. This is the needs assessment. This is procurement and donations. And finally, we go to the inventories and maintenance part, which are absolutely indispensable. We have a new book that just came out from the Priority Medical Devices. That was the Essential Model List of In Vitro Diagnostics that just came out in 2018. First, we are defining to select the technologies needed for health interventions and health facilities. So we have these books, and you can download them. They are even in more than one language. The Interagency List of Priority Medical Devices for Reproductive Health, Maternal, Newborn, and Child. Another one for cancer care. And we're now developing this book on heart disease for stroke and diabetes. And this is an example. We take a health condition like stroke or diabetes, we find the clinical guideline, then we find the clinical intervention, then we have to define which are the devices that are required for those interventions, and then we have the ICD, the publications, and then we do the dissemination. This is an example of our cancer book that has the cancer, the chapter on surgery and the navigation diagram, where here you can see prevention, diagnostic, screening, treatment. So we need to follow the patient all along their life cycle. And here we have, for example, surgery. We can have surgery at primary care, at secondary care, and tertiary care. In our book, we have the general medical devices list for surgery. So here you have anesthesia machines, suction machines, infusion pump. But then you also have specific devices for surgery by cancer type, for example, biopsy gun or mastectomy set, etc. And we have the list of all the sets that are needed, like basic surgery set or suture setting or dressing setting, so that we have the list of all the instruments that are needed here. No? Now for the new book that we're doing on cardiac diseases, we are also developing what are the things that we need for general surgery or for specialized surgery for cardiovascular, ophthalmic, or neurological surgery. What we need to do is once we have the list, we need to support the registration and the supply side. So we have as WHO provided guidance on the regulation of devices, on the selection of the assessment, on the procurement and selection and training. But these things are very complicated. They're not easy, and they're done by many people. Most of these are done by at a higher level, at the government level. Most of this is done at hospital level or health facility level. We are also in WHO searching for new solutions. And so we have the Compendium of Innovative Technologies that started in 2011. And we have 2014, 2016, 2017, and some of actually the gasless laparoscopic system, for example, that was just presented before. It is in one of our books. So I'm just telling you here, for example, we have a new anesthesia machine that was developed in the US. We have a prototype for portable sterilizer, and we have the anesthesia machine that was developed in 2014 in the UK, and it's in the book. So, and then here you can go to the details of who is providing, who is the company, the organization that is doing that. But then it doesn't matter that we have the technologies developed. They are still not available where needed. And that is where we need to find out why. So we did a survey in 2015 saying, why do you not have access? And well, they said, well, because there's a bidding process, because there's lack of available technical specifications, because I'm not aware of which devices are available, because there's lack of information of these innovative products, because I have no funds or inability to purchase, or prefer proven products from well-known manufacturers. So these are things that we have studied, and we're trying to target all these needs. We also have developed a feasibility tool for innovative technology, so that we just don't take care of the need. Of course, it has to be driven by need, but we need to follow up with the regulatory, the procurement, with the settings, with the cost, with the use. So we should not forget all the items that go after the innovation. We also have 4 normal devices that are not innovative, so like an oxygen concentrator, aspirators, blood pressure measurement, etc. We also have documents in WHO. We need to have biomedical engineers that regulate devices, because in many countries is still pharmacies regulating devices. So this is causing a serious problem, and we need to increase the regulatory status of medical devices in many countries, as you can see here. We also need to have a nomenclature. So WHO is now working on an international nomenclature so that we all have the same name, because if each one names it different, or if we have different nomenclature systems, we're not talking to each other, and then we cannot harmonize. It is difficult for procurement, for regulation, for everything. Then we need to determine which are the devices that are needed for type of hospital or number of equipment. But we also need to have the recommendation of how many biomedical engineers we need. And I left this slide for you so that you can see the density of biomedical engineers in 2017, which now we're getting really in many low and middle income countries, a big representation of biomedical engineers. We need still to define and help them on their activities, profile, functions, indicators to make a WHO recommendation, but the book is already out and you can review it. And then finally, what we want to do is consolidate all the knowledge base that we have in WHO, and we're developing an information system that is called Medevis. We hope it will be ready for 2020, in which we can have all the devices that are innovative, the regulations, the assessment, the interventions, cost of different devices. And so, finally, the challenge is how to select and use really effective, safe, and appropriate health technologies in all patients globally. We need to have empathy to users, to simplify the training, to listen to the patient's needs, to innovate, to solve real needs, to dream of a better health, to empower the users, and really to develop technologies that can enhance healthcare delivery to vulnerable population, especially to those that need it the most. We have helps with the NGOs in official relations that we have, as you can recognize some logos there. And we also have collaborating centers all around the world. So if the University of Leeds or any of you would like to become a collaborating center and are able to help us, we really need a lot of help in medical devices. So this last slide is that you always remember that a patient is at the end of all our activities, and they deserve our technical knowledge, but most of all, our passion, our honesty, hard work, and collaborating all together to achieve. Thank you very much.
Adriana, can you hear me as I'm speaking to you just now? I don't know if I maybe better stand near the laptop. Can we invite questions or comments from the audience then? Got the microphones.
Yes?
Can you get is it possible to have your video on?
Yeah.
So, any questions from the audience or points? Okay, Joseph, do you have any questions for Adriana from the WHO? Okay, no problem, we'll come to you in a second. Do you have a question, Joseph?
Thank you so much.
Thank you.
My name is Maria. I'm also from Rwanda. I'm excited to be in this conference. As you've stated recently, among the challenges you addressed, there is equity training. So, we want to make global health equity for everyone. As they still have this kind of inequity training of biomedical engineers, and also we've already heard that in some settings we have no engineers. So, how are you going to overcome that challenge as WHO? Thank you.
Thanks,
Thank you very much.
Do you want to answer that?
Yeah, I can. We are the release of the book of Human Resources for Medical Devices was our first issue, so that people know who they are, what they do, and their profile. So now this was sent to all ministers of health. So we're trying to improve that. but it is also the education, the ministries of education that have to target that. We're also working with the International Labour Organization to have a recognition for biomedical engineers and then be able to have more visibility and the statistics of it. But that is what we can do. Over.
Thank you very much, Adriana. Is it possible for you to turn your video on so the House can see you? And
yeah, I tried to do that twice.
It's like a top. It's like a video link on the top of the screen.
I know that, but and it was there.
A different version.
Sorry, I shouldn't be telling the WHO medical devices what to do.
No. On the contrary, there's no problem.
So
it was.
There was a question elsewhere, was there? Yeah. No. Sorry, I can't see. Can you put your hand up if you were wanting to ask a question? At the front, right.
Thank you. Alliance Nuclear from Burundi. My question is, one of the issues raised is bigger companies with more money buying these intellectual properties, and so we lose the value to the patient. Is there a system the World Health Organization has installed to protect these innovators from LMICs to keep their innovations for their patients? Thank you.
Thank you. Any thoughts, Adriana?
I'm not sure I listened to exactly what he was asking. It was about the IP?
Yes, that's right. There were comments earlier about the difficulty of wanting to innovate altruistically, but then not lose the intellectual property, the IP, to those who might seek profit from your innovation.
Yeah, what we have seen is, we do have a book that's called Local Production and Technology Transfer, and that is talking about all the things about intellectual property and innovation. And we are trying to work with some companies to get the intellectual property so that it can become like an open source and work with them. But it has not been easy. It is there are many interests in the industry, as you all know. No, but we'll try.
Thank you.
Thank you. But I just wanted to let you know that I'm just one person. So I wish I could do many more things, but it's not possible.
Yeah, there's a lot.
So I would welcome any help also.
Yes, right.
Thank you very much, Adriana. That's very kind of you to come on live stream. Do you have a final take-home message for students, doctors, engineers who are in this room as well as in Rwanda before we break for lunch?
Thank you very much. I really want to thank you and being so patient with me. Secondly is never stop dreaming that we can have a better world and that we can have really the technology that is needed for those that need it the most. We have to strive all together. It is not easy, but we need to get more visibility and shout of the need of medical technology appropriate to the settings. So keep on working, and you know you have an advocate and an advisor here inside WHO. Even though I'm one, I'm strong with all of you. But keep on working and do not lose the passion, because we really need to keep on working together. So I encourage you to keep on working. I encourage you to all, as students, spend some time in a hospital. Not just go to Rwanda or to any country and just try to improvise or innovate there. Go to your own UK hospitals, work there, be like a clinical engineer, work on knowing exactly how the things are done there before you go elsewhere. So that is just a suggestion. We really want everybody, I wish everybody can, biomedical engineer can have a stay in a hospital so that they really know, before innovating something, really know how it's used, who is the user, how the patient receives it, how the healthcare worker, etc. So keep in mind healthcare workers and users. Thank you very much. I really, really congratulate you and keep on going.
Excellent. Thank you very much for your encouraging words. Can we have a round of applause, please? Thank you very much, Adriana. It's been a pleasure to have you live stream, and we hope you have a really nice day in Geneva.
Thank you very much.
Okay, thank you. Bye.
Thank you. Bye-bye.
Excellent. Thank you very much for your patience, guys. Some of you who are surgeons, you'll see that when complications happen, you just have to stay calm and just sort of carry on. The only problem that I had is I didn't have a mask on my face, so you could just see what was going on. But anyways, great, we were sorted. So it's 12:25. We are going to come back into the hall at 1:15. So the way it's going to happen is half of you from here, you can go up the steps and into the theatre bar where you've got lunch and refreshments up there, and the posters as well. So I request all the poster presenters to also grab their lunch and stay upstairs. And then the rest of you can go into the Millennium room, and there will be lunch and posters, and all our exhibitors will be there as well. So please make a move, and we'll see you again.
Well done. Good job.
Stuart, thanks very much for holding the phone.